This is lesson 6.5, Conditions for Rhombuses, Rectangles, and Squares. So what we want to do today is to be able to determine whether a parallelogram is a rhombus or a rectangle. So one of the most important things for you to understand is that you can determine whether a parallelogram is a rhombus or a rectangle based on the properties of its diagonals. So let's take a look at theorem 616. So the theorem says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So this is the converse of a theorem that we've already learned that said if ABCD is a rhombus, then its angles, its diagonals, form a perpendicular. Okay, and we have another theorem that is the converse of one that we've already learned. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So you see that segment BD bisects angle B into two congruent parts and bisects angle D into two congruent parts. So it is a rhombus. Now we have theorem 618. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. This is another converse statement because before we learned if the parallelogram is a rectangle, then the diagonals are congruent. So on all of these theorems that we're learning today, we're just learning to look at it in a different way. So none of this is new. We're just looking at it from a different perspective. So now in problem 1, they want to see if we can conclude that if the parallelogram is a rhombus, a rectangle, or a square, and we also need to explain. So when we look at A, what do we notice? Oh, I have a diagonal. It bisects my angle. So what do you think I have? So this parallelogram is a rhombus. Now let's look at B. So we have two diagonals. Oh, I see that they form a right angle. Let's see. Tell me what you think. So as I look at this a little more closely, what do you notice about the diagonals? They're congruent, right? So my diagonals are congruent. So what does that mean? So that means I have a parallelogram that is a rectangle. Now let's go another step. Oh, my diagonals form a perpendicular. So what does that tell me? That tells me I have a rhombus. Now, what shape is both a rhombus and a rectangle? A square. So a square would be our most precise conclusion. Now let's take a look at problem 2. So we're going to use the properties of special parallelograms, and they want to know for what value of x is parallelogram ABCD a rhombus. Okay, well, what do we know about the diagonals and the angles of the rhombus. Okay, the diagonal bisects the angle, so I know that angle ABD is congruent to angle CBD. So I am going to say 6x minus 2 is equal to 4x plus 8. And go ahead and pause and you finish working, and then you can resume and see if we got the same thing. So now we're going to subtract 4x from both sides. So now I have 2x. Let's see. And I'm going to add 2. So that's equal to 10. I'm going to divide both sides by 2. So I have x is equal to 5. And so the value of x would need to be 5 in order for this to be a rhombus. Now, what do you think we would do for this one? For what value of y is parallelogram DEFG a rectangle? Now remember, what do we know about the diagonals of rectangles? We know that they are congruent. So we would say 5y plus 3 is equal to 7y minus 5. I'm going to subtract 5y from both sides. And then I'm going to add 5 to both sides. So I get 8 is equal to 2y. Divide both sides by 2. So 4 is equal to y. Okay, so this one we're just going to kind of talk through, and I'll jot down a few notes. So we want to use the properties of parallelograms. So builders use properties of diagonals to square up rectangular shapes like building frames, playing field boundaries. Okay, so suppose you were a volunteer volunteering to build a rectangular patio for a youth center. How could you use the properties of diagonals to locate the four corners? What do you think? Well, if we want it to be a, let's see, does it say it needs to be a rectangle? It says it needs to, you're helping build a rectangular patio. So what do we know about these? Well, I know that if the diagonals of a quadrilateral bisect each other, then I have a parallelogram. The other thing I know is if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So I'm going to erase one of these little marks because it says we want to have a rectangle. So I know that this segment and this segment are the same length. And if I put the strings right in the center, right in the middle, then both of these sides will all be congruent. So what can we do? Well, we can cut two pieces of rope that will be the diagonals of the foundation of the rectangle. So we'll cut them the same length, and then we'll join the two pieces in the center at their midpoints, and then we'll pull the ropes taut, and that will be the endpoints of the rectangle.